All right, so now we're going to talk about creating an evaluation measure. Uh, let's remember what our goal is. All right, so we've got a goal here. What we're aiming to do is to end up with means to predict the performance of search engines. In particular, let's think about always sort of the context that we have search engines A and B. So we have two search engines. Usually it's going to be a search engine that's our current search engine, and then we're going to make some change to it. And we want to know whether that change is an improvement or not. So we're going to be comparing basically the idea of two search engines. But we want to do this comparison without deploying and testing on live users. All right, well, certainly wouldn't want them on dead ones, but I mean, we don't want to have to go to the trouble to actually do some sort of test with people in a laboratory. We don't want to have to actually deploy it to a live site and try to measure differences. We want to do this very first efficient, low-cost methodology of an offline evaluation because we want to get an initial sense of the degree to which this change could actually improve things on the search engine. We are answering the question, which is the better search engine? All right. Now, what's the framework that we do this in? Again, our world is, we've already talked about observe, and I gave us lots of general things that we understand about search. There's of course lots more, but that's sort of the foundation of most of what we're going to need to know here. Our next step after we observe a system is we're going to work on modeling. Then we're going to end up predicting. All right, so today we're working on modeling, and we won't finish modeling today. We're going to start on sort of creating the model. After we create the model, then we'll have to figure out how to calibrate it and how to validate it. Today is largely about creation of the model. Okay, so that's where we're headed. We want to make this prediction. We want to do it in an offline, efficient, affordable fashion without needing to involve live humans. The idea being is that we could try out lots of different things to improve our search engine. We can even use this system, this model, when making these predictions, to be able to actually even optimize the parameters of an algorithm, for example. That might require thousands of different tests, something that we would never want to do with actual people. All right, so what do we know? All right, for getting us going with our modeling. Well, we know the following. One, we know that people interact with the search engine. All right, so this is, humans actually use them, so they interact with the search engine, and interaction takes time. And that's a real component to it, absolutely. It's not as though everything takes the same amount of time, or there's no notion of time. Like, we're talking about a real system here, people really using it, and some things take longer than other things. And so time ends up being a really critical component of our notion of what we're looking at here. And indeed, this goes along with that we assume people interact. So when I say interact, it really means, yeah, you're going to search, okay, to receive some benefit basically from the search engine. And we could, for example, if we wanted to, and it's quite popular to talk about benefit as some sort of gain. I'll come back to this, but you're going to see this word gain in the literature. All right, but let's just, for us, we're going to have our gain, if we wanted to talk about gain, be something very concrete, which is we're going to be aiming to model and make a prediction of the number of relevant documents found. By the user, okay, by the person using the system. With the big idea then being that this all leads to, we put this, we're going to interact and it takes time. Our goal is to find these relevant documents. Is this sort of, we're going to deal with informational searches. People might need to find more than one document. And basically a system that allows us to find, let's say, n relevant documents in less time is better than a system that takes more time. So if we're going to find, 4 relevant documents, 3 relevant documents, even just one, whatever it is, for the amount of relevant documents that we're finding, a search engine that is able to find them in less time is better than one that takes more time. And I think that's something we can all largely agree with. It effectively is a more efficient, for us, the humans, search engine. We're able to get our information out of that system faster. That pleases us, that's good. And so this is how it all flows together. We're going to interact. It's going to take time. Our goal is to find a certain number of relevant documents, or to find relevant documents. The system that gets them to us the fastest. And I don't just mean like, how fast the page refreshes. I mean, we interact with it. And, if you're not finding many relevant documents, I might be spending a fair amount of time looking at non-relevant documents. And that's not a very efficient use of my time. But if you're returning lots of relevant documents to me, it's going to be easy. I'm going to click, view. It's just going to be, I'm going to be swimming in relevant documents. And that's great. All right. So let's make this a little bit more visual for ourselves. Let's make a plot of sort of what it is that we're aiming to talk about here. All right. So over here, our vertical axis will be the cumulative number of relevant documents found. So you find one, you found one relevant document. You find another, now you found 2, and another you found 3. It accumulates, okay? And so there we go. We're going to make a nice axis here. And then on the horizontal axis, we're going to put time, with time increasing. So this is time 0 on out. And we could envision, again, we're going to compare, this is, we've got a user experience, so to speak, with systems A and B. All right. Now, system B, let's do system A first. System A, we're going to have it look something like it goes up, levels out, you get another little bump, and then continues with an arc here. And so this is system A. On the other hand, with system B, get a really slow start. Not much happens, but then it takes off rapid rise, but then it also levels off and ends up over here. Okay, this is just hypothetical. This is an illustrative example. So over time, as the person is using these search engines, one of the things that's interesting to think about is, all right, well, we can go ahead and we could say, well, maybe the person only had T1 amount of time to search. Okay, so at this point in time, if the person only had this amount of time, it's like, oh, I got to find something in the next 3 minutes. Who knows what it is, okay? That's all the time I have. I want to find it fast. So system B is superior. It's able in that amount of time for the user to find more material. All right. But on the other hand, let's say I got a lot more time available. I could search all the way out to T2 if I kept going, so take a lot more time. And in this case, we can see that system A is superior. All right. Now, the thing to note about this, so we've got these two times, is that basically stopping your search at different times gives us different answers about which is better. All right, so which system is better? And this is certainly something for us to consider, because what if our user population is not really spending much time searching? What if they tend to be down, what if they're really always pressed and they're not willing to spend much time? Well then system A is definitely probably going to be better because they are able to find something really quickly. But if our users in general have more time to spend, system B looks better. But if our users have a huge amount of time available, maybe system A will shine out and be better for them. And we're eventually going to get to the point where we talk about there's probably some distribution of amount of times that our population of users have to search. And from that distribution, then we could get an average overall expected amount of relevant documents found based upon which system curve we're looking at, and then make a final decision about which system is better than the other one. Now, so that's when time constrains you. It is possible, we're not going to dig into it, but it is also absolutely possible that maybe you define, so we will be defining our model in terms of the amount of time someone has available that they're willing to put in for the search. This is sort of how much they're willing to invest in their effort, so to speak, in the search. There's another notion, though. You could also be talking about the amount of documents or relevant documents that you need to find to be satisfied. So you might have some information need and you need R1 amount of documents, or you could have different information need that actually requires R2. Okay, and so maybe R1 is I need to find maybe 2 documents. Maybe R2 is I need at least 4 documents. This is a real serious information need. I need to see multiple sources. It's really important to me, and so the one that can get me the most relevant documents is my preferred system. Again, and maybe if you had a really small information need, the one that gets it to you really fast is better than the other one that's a little slow to take off to actually help you find things. So, all right, I've already said this, but I want to mention that, put it in writing on the board, which is a better system. Well, it depends, doesn't it? If these were the actual curves of A and B over time that people use the systems, it's certainly going to depend on how long or how much time a user has available for their search. All right. Likewise, it also is going to depend on how much information they need. Now, again, I will note, as we proceed forward on the model we're working on today, we're not going to worry about the amount of information they need. We're going to always, we're actually going to end up modeling under the assumption that they need a fair amount of information. That's the tasks that we're modeling, and we're going to focus then on the amount of time that they spend. But you could certainly envision building a model that could take both of these factors into consideration. And there are people who work on models where they have looked at and they model the amount of information needed. And there's other ones that then also incorporate some measure of effort. In my opinion, time, when we're dealing with an interactive retrieval system, and that the way that the user interface is built can affect the amount of time it takes me to find material, I think actually modeling time then is really critical, because that tells us about the total whole system. It includes the user interface in that analysis. We don't just throw out the user interface. The interface actually matters. The interface changes the rate at which people can find information. And so we need to consider that in our designs, especially if we want to be able to make predictions that are reflective of what will happen when people are actually using that user interface. All right. So time, I think, is critical if you're doing interaction and you care about that user interface. I would always have this, and if I wanted to, I could also develop a model that incorporates the amount of information need. But to keep things simple for our explanation here, we're only going to focus on time versus the cumulative number of relevant documents found. Now, I want to mention one of the things here, though, that this is shown. This is like some users using this thing, for example. Okay. You know, just be really clear, like, you know, you cannot do this with live people or real people or whatever we want to say. And why is that? Well, if I sit down a person with search engine A and say, I want you to find information about, fuel efficiency for your car. Okay, I'm going to start reading about fuel efficiency. All right. They do that, and they'll see documents. They'll learn stuff about fuel efficiency. They will change. Then if I put them down into system B, they're not going to behave the same way as they did when they used system A. They're a different person now. Their brain has changed. They've learned about fuel efficiency in their cars. We cannot easily make a comparison on the same topic, the same information need for that user. Basically, you do it once, you're a different person. You can't then compare it to another system. You could collect a bunch of information needs on one system and compare them to a bunch of different information needs on the other system and look at those averages, and that might be possible. But often we cannot easily do this directly on the same information. We can't do it on the same information need with two different systems in the way that we envision an interactive system. Another thing to note about this is that these curves that we will have here, these curves are different for different information needs. So that's because the information systems can behave differently for different things that we're looking for. Some of them might be really good at finding things about celebrities, but really bad for scientific research. It's just possible. All right. Likewise, these curves would be different for different users. Some people are much faster at processing information. Some people make more mistakes than other people. And so a curve like this is really, this is a user's experience with the system. Okay, this is how they respond, and different people will behave differently with the system. Okay, so we've got information needs, users. You know, and the reality is the same user at different times. If I had a way to take a person and have them use it, and then sort of wipe their mind and have them use it again, I'm very likely to get somewhat different results, even for the same system. And that's because humans are not computers. Humans are not machines. They are different. And so there's a lot of actual sort of stochastic nature, randomness to this. You know, we would have to consider, when we look at evaluating search engines, we're going to have to consider many different information needs, many different topics, whatever we want to call them, because the search engines could behave differently on them. We also have to take into consideration the different types of people that use these search engines. Some of them, again, are going to behave very differently for the same system. So we have this sort of variability from the information needs, variability from the users, and as well, there could be intrinsically variability with regard to the same user using it multiple times. We probably wouldn't model that, but we could absolutely model that. And so all of these then actually result in, it's kind of like these lines, if we were to sort of average it all out, you know, it's not gonna be so perfect. It's going to be, I'm going to be like comparing, you know, distributions of performance rather than just taking slices and cuts. All right. So this is just to note that there is a lot to consider here. The one thing that we will absolutely take care of when we deal with this is, in information retrieval, we are always examining multiple information needs. You know, sort of the standard that has evolved over time is we need to look at basically about at least 50. You could probably get by with fewer, but absolutely the more you have that you consider for information needs, you can think of these as queries, different types of queries, okay? So 50 is sort of a minimum that we look at. The major commercial search engines, they look at thousands, okay? They look at a very wide range of information needs when they evaluate the quality of the search engine. There are not as many evaluation measures out there that consider the variability of the users. There are some. This is a bit more on the research topic, and certainly even the variability of an individual user. These are more cutting edge research things. We do have the ability, and we've done the work to look at variability on the users and an individual user. I probably will not get to that in this course. We'll look at information needs, okay, and as well we'll talk about that. We'll get to the notion that there's a distribution of the amount of time that our users are willing to spend. And that will be we'll try to keep this model pretty simple to start with. But you know, where are you limited? You're limited by what you can handle and what is worthwhile in modeling and what sort of insights you can see. But absolutely. So there's a lot of things to possibly consider. The big things here, again, being this notion of these overall curves over time, and then at different times, we can get different answers back. All right. So that's the key idea, abstract notion of what we're setting up to model, okay, and the way that we're going to think about modeling it, which is this cumulative documents, relevant documents found over time. Okay, so now let's get into, now that we've got a feel for where we're headed with our goal and how this is in the abstract going to work for us, let's go ahead and look at building our model in more depth. All right, so let's start with the interface. Okay, so we need to think about what it is that the user is actually going to be interacting with. This is an important part if we want to note eventually the true performance of a system. We need to have a model that works at the user interface level, because real people will use a real interface. The closer our model is to reality, the better our predictions should be. All right, so what are we going to do? We're going to definitely keep this pretty simple, but in general, we're going to have a notion that we're going to take a search engine results page. This is, in the lingo of the industry, a SERP. You can be really cool. Talk about the SERP. All right. And how to model it? Well, we're going to have a very simple view of this guy. You've got a page, and I'm not going to draw it much because I don't have a lot of space on the whiteboard. But again, we're going to have some sort of envision that you kind of like, we got a query box, and you hit go, and again, you get these results back, 1, 2, on down, maybe 10 links on the page, some little button down here to see more results or something like that. The actual web page that you would see in a modern search engine is massively more complex than this. We're going to actually even, I'm going to list what we're doing with our user interface here, but we are really going to simplify the modern search engine interface. We're not going to have ads. We're not going to have little call out boxes and things like that. We're not going to have images on the page. We are going to have a notion that search is done, then you get a ranked list of results, that they have a summary that you can look at to try to decide whether it's relevant or not, to decide whether you want to click on it, and then you can click on it, you can go end up at the full page. And when you can read the full page, then you can decide whether you want to save it, let's say, whether or not you have found something that is relevant. And then you can hit a back button, get back, and come on down. All right, I just said it all, but let's write it down. So always, when it comes to modeling things, we work to simplify, simplify, simplify. The more complex it is, the harder it is for us to model, and the more difficult it will probably be for us to extract a signal out of our model. So we want a simple enough model that we can control and understand it, but something that still holds enough reality that it produces a useful prediction of what it is that we want to measure. And again, in this case, the number of relevant documents someone finds. So how can we do it? Again, I already said this, but what we're going to do is our simple interface that we're going to model is just going to simply display results, so search results from a query. All right. We are not going to model how a user generates the query. We're not going to get in their brain and figure that out. Or we're not going to even bother to model the time to enter the query, for example. They got to type it and things like that and hit the button. That's not what we're going to do. We're going to simplify it. It's just going to, there's going to somehow have been a query run, and results are going to be shown for the user. Likewise, our interface is unlike any you've ever used before, but we are going to make it so that, nope, there's no such thing as to reformulate your query. So this is what we call a one-shot deal. You get your query, and that's it. You're like, this is not very realistic. Well, it's a simplification. It lets us analyze and understand the search engine with regard to how well does it respond to a single query, and what could a user find in those search results. Yes, real users change their mind. They put in new queries. They put in multiple queries. They have search sessions. the interface needs to support that. And one of the ways that we're going to say is like, no, we're not going to do that. No query boxes, no way to change it. So the user is just forced to have, they've maybe put in a query on a previous page and now they get search results and that's it. And no hitting back to get back to that original query. It's a sort of a fantasy, but it's a necessary simplification for us to make some progress on doing this model. The user consumes, they read basically only these ranked results. Now you could choose whether or not we would say that this is actually in the modeling of the user, in the modeling of the interface. It's got to go somewhere though. So I've described it here as in the interface. Yep, I'm actually going to get rid of that next button. So there's no next page button in this simulation. The ranking that we have here that returns these results, the ranking just goes on forever. If the user had all the time in the world, the user could go until they found and looked at every single document in the collection, because the entire collection is effectively ranked. So that's possible, but there's no notion of, oh, should I decide to go to the next page? Likewise, we're not even having anything, I'm not even going to bother to put it on here, but there's no notion of some things aren't visible off the screen. It's just that someone's got an ability to work down this ranked list and to try to find relevant documents. The only thing on this page, this app, is the ranked list. And they've got their summaries. That can be clicked on. To view the document or to view the web page that it's summarizing. And then finally, I don't really have room on the whiteboard, but I'll just stick it in here. Yes, there is a back button. So there is a way for a user, when they click on the page, there's a way for them to hit the back button and come back to the rank list. All right, so the interface does support the ability for them to click, go view a document, and come back to the rank list. So it's super simple. Somehow a query has been run and you've got a list of ranked results. So if I was to clean this up, we don't really even have a button or a search box there. It's just some sort of set of results. There's no next. This is all it is a bunch of search results. They do have summaries though, and they can click to decide whether to view it, or they can just to not actually click. So that's our interface. So but we have to define it. We always need to know what it is that we are actually going to be modeling here in the user interface. All right. Continuing on, we're going to need to model the user. What I think is a good idea for me right now is to take a small pause in the recording and then resume so that I don't end up with these super long videos. I'll be back in just a moment.